Hello everyone, September 26th here. Alright, let's go right into it. Transform for chessboard, chessboard. You're given n by n binary board. In each move you can swap any two rows with each other or any two columns with each other. Oh my god, return the minimum number of moves to transform the board into a chessboard if the task is possible. Return -1 if impossible. Chessboard is a board where no zeros or ones are four directionally adjacent. So that's a chessboard, right? So what do? We swap these and then swap these. Wait, what? That's just labeled wrong. Shouldn't it be like one is, the color is wrong. First swap the first and second column, and swap the second and third row. That's already good. We cannot do. Oh man, it's not even hints. Oh, okay. Let's think. So chessboard, this works. So like if we swap it, it still works, right? So what we want is 1 0 1 0, and then it's 0 1 0 1. Oh, where do I even start? This is, oh man, where do we start? Let's see. What does these things do? So, swap rows will not change. It will. Swap rows will not change rows, but it will change the orientation of the columns, right? So therefore, if I have, say, 0 0 1 1, then this is our orientation. And in order to make it into the chessboard, so we need to 0 1 0 1 or 1 0 1 0, right? So to make that change, we either swap this with this, right? A 0, no, this and this. The first row, so like, okay, let's do this. The final orientation is going to be, and let's just say 0 1 0 1. Let's just look at the first column. So the final orientation either be 0 1 0 1, right? If it's 0 1 0 1, then these two are in the wrong position, so we need to swap them. And once we swap these, we say the first column is done. And after we swap, we take a look at the second column. So we swap the second and the third. We have 1 0, right? If we swap these two, this would be 0 1. No. Again, I was saying second and then the fourth. No, the second and third. These two, 0 1 0 1. These two. So if we swap these two, this is gonna be a 1 0 1 0. That's good. This is gonna be a 1 0 1 0, and this is gonna be 0 1 0. So we're done. So after we swap this, we have fixed all the columns, right? All the columns are done. Now we're gonna look at the rows, right? So if we look at the rows again, we have 0 1 1 0. So we need to swap first two. So we swap first two. It works. We check it works because when we swap these, the columns. Wait, do the columns also change? It do change, right? Yeah, so like after we, like let's say we swap rows first. And when we swap rows, right, we don't care about columns. What do you mean by we don't care about columns? Well, when we swap rows, we don't care about each row, but we will change column. So when we swap columns, right, when we swap columns, we won't change columns. Columns will stay good, but we will alter rows. So we say we change this So after we swap the rows, the columns are good. So we don't worry about a column anymore. Now we're going to swap columns, which is we will change the rows. Now when we swap columns, we check, 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 and then it's good. Then we're good, right? Okay. I mean, think about it. No matter how many moves, like the maximum moves you make, eventually we have to make sure each row and each column be good, right? That's the goal. So if we go each column, let's just say column by column, we're gonna swap rows first to make sure that each column is correct. But keep in mind, every time you swap rows, right, you are affecting all the columns. Therefore, as we go through, right, there must be some ways of swapping that will allow the rows to be... Yeah, so I think this problem can be separated into two parts. We can swap the rows to get the columns in check, right? Because this step is independent of swapping columns to get the rows in check. So we swap the rows to get the columns in check. And we have a bunch of 0 and 1s, right? A bunch of 0 and 1s to start with for each column. And we look at the first column, right? And we use first column as the proxy, because eventually if it works, it must work for first column as well. So first column we have a bunch of 0s, bunch of 1s. We don't know where to swap, right? So let's say we check the first one, right? So the first one can either be itself or we can swap it. I feel like it's, like I said, it's two steps. Do the row swap, right, and then do the column swap. It's two steps, and the two steps are independent, and we just add the final result together, and that should be fine. And the two steps are actually we're doing the exact same thing. So maybe it's also possible to simplify, to generalize the logic. So let's just say we swap rows, right, and look at each column. Now, if we look at each column, from the first column, we can make a swap, and we can make another swap. So, like what? Like we do all types of swap to get a column in check, right? Let's say we do the minimum number of steps. The minimum number of steps to make the first column in check. And after we make the first column in check, we check all the other columns to see if they all match. If they do not match, then then what? Because when you swap, everybody else is swapping with you, right? Or we can identify... Okay, how about we identify all the columns that are the same, right? Actually, I don't want to swap. Yeah, that's fine. We identify all the columns that are the same. So when we swap the rows, these will change the same way. So we identify what are the patterns, right? What are the patterns for all the columns? Let's say we find all the patterns for all the columns, okay? Then we say we actually can treat the column as a row, so it'll be easier for me to visualize. So we have all that, and then we start swapping, right? We start swapping. So I say we have, like in this case, we have 2 for the column, right? We have 2 different ways of ordering columns. And when we're swapping them, oh, there's also another thing. Because it has to be in this shape, right? That means if we have the same pattern, right? I mean, this columns is different pattern, but the rows is the same pattern. If we have same pattern consecutively, let's swap them out. No, that's not the issue. Okay. And I'm just thinking out loud, really loud now. So like we find a pattern, right? We find a pattern first, and then we can swap them to make the main check. But we need to make sure that after the swap, we need to have half of them with one type and half of them with the other type, right? That's the goal. So given all the patterns, if the starting pattern are all different, then that's a good question. Would that even be possible if the starting patterns are all different? I mix the rows. It's easier for me to think of rows. Let's just say we're going to swap columns and then we'll look at the rows. So let's say we have 5, right? And then if we want to swap, we can also check, because he didn't really say, so we can check to see if it even fits, right? Which means, like, in case of, that should be -1, right? In case of, I don't like this, I just tried this, right? Like, if I have this, the number of 1s and 0s are not equal, that is going to give me a -1. Right? So that's something we can check. The number of 1s must equal to the number of 0s. Is that true? That's not strictly true because it's a 3 by 3. If it's an even number, then it's the same. If it's odd number, 1, 2, 3, 4, 5, 1, 2, 3, 4. So it has to be the absolute value of the number of zeros minus absolute value, not absolute, just the number of zeros minus the number of ones. The absolute value of that must be smaller or equal to 1. If it's any more than that, then we know it's a no-go. So that's the first check. After that first check, now we have, what I'm saying is just, let's do this. Let's say like there'll be no 2 pattern is the same, right? If we have like no patterns are the same, then when we swap, right? And then this will be and then when we swap, these will give me good result. Yeah, I'm writing on just a piece of paper, but these will give me bad result. So this is impossible, right? This is impossible because no matter how you swap it, It's not going to work. The number of patterns, right? Because if everything is of the same pattern, then it's not going to work. So everything is the same pattern is not going to work. And also, if, let's say we have n rows, right, and then we find out, we're going to count the patterns, right? Count the patterns. If the patterns are, let's say, one pattern has more than half, right? If one pattern occupies more than half, then that's not going to work, because the same pattern can only appear, right? Because whatever happens, I have a pattern, right? And then I have a repeat of the same pattern. And all of those, no matter how you change, they will be the same. Right? After the change, the pattern will be the same. And the same pattern can only exist half of the time, or half minus 1. Right? That's the maximum number of times the same pattern can appear. So if a pattern, like here, appears more than once, because this is 2, so we know the maximum number of times it can appear is 1. And if it's 3, then the maximum number of times it can appear is 2, right? So if that happens, then it's a no-go. So that's why this one is a no-go. So now we are restricting, and we are restricting on the number of ones, number of zeros, and now we're talking about number of patterns. And the patterns can be simplified because each row can be think of as a binary number, right? So which means if we take each row as a binary number, then we say the same number, the same value cannot appear more than n divided by 2 times. And n is the size, the length, right? N divided by 2, integer division. It cannot be more than that. Right? That's another check. That is another check. So the first check is the total number of ones and total number of zeros. The second check is, can the second check be, let's say, the same as the first check? The number of ones? No, it cannot, because this one, the number of ones, it match. But it could be like the number of ones, yeah, and then this was just number of ones, and yeah, this match the things, the second check, but the first check fails. So we need to do 2 checks, right? First, number of ones has to be n divided by 2, or n divided by, depending on n, right? Depending on n. So the number of ones and the number of zeros, the difference between the two cannot be larger than 1. The second check is the pattern, right? The pattern. So we go two rounds. So first round we can say the rows, right? And then second round we can actually turn this matrix into consider these are all binary numbers, right? So, and also when you check the patterns on the columns. Mm-hmm. So after these 2 checks, we're left with a matrix that has an equal number of, like a valid number of ones and zeros, and for the pattern, let's just say the row for the patterns, then we have no one pattern that is more than half, right? Okay, now the question is, are we required to have, but if you think about it, right, if I have a pattern, like for the row, I have a pattern for the row, and I can do whatever change on this pattern. The question is, if I have a pattern and it will, let's say, result into this one, right? Will it be possible to have another pattern? A pattern different, like 2 different patterns. Is it possible for 2 different patterns to end up in the same pattern after the same number of moves? I think that the answer is no, you can't. right? Given if two patterns are different, and you start moving them, how could they end up in the same pattern after the same amount of moves? So it's impossible. So the only possibility, right? Now we're like really narrowing down. The only possible to have this type of swapping to work is that the starting position, we only have two patterns, right? They only have two patterns, and each pattern will count half, right? Will count half of the length. Okay, that's the only way for us to make moves, so that at the end we will end up in the desired orientation. That's the only possibility. Therefore, I think we can throw out a lot just by checking the patterns, right? If we have 3 patterns, then no, that's no-go, right? That's a no-go, because in the end we only have 2, right? So we must only have 2 patterns to start with, and each pattern must occupy half of the number, right? If like all these 3, well, now we have 3 checks, and each check will run on the rows, on the columns, on both, right? But of course, if we want to run on the columns, we probably we need to transpose. Right? We need to transpose the matrix, which is easy to do. It's just like how do you transpose? So the first column is the first row. Just swap this, swap this, swap this, right? And then what? And then the second column is going to be the second row. Third column, the third row. Now just write it out. It's fine. Just write it out. Okay, so yeah, we'll worry about this later. So now what? Now we identify. So if we pass all 3 tests, now we say a matrix is possible to go through some column changes to make it so that we have this shape. This shape. Now the question is it even possible to make it into this shape, right? But there is a certain requirement. It's not like you can give it any 2 patterns you can achieve this. I don't think so. Right? So let's say, and the pattern itself. Oh, hold on. The requirement is not just the total number of 1s and 0s. It's the number of 1s and 0s for each row and for each column must be equal. Or like, that's the real requirement. Do we have to? Yeah, we do have to count, right? Because the binary number won't tell you that. I don't think you can get from binary numbers. You have to check every row, right? So check every row. We're gonna get the number of 1s, the number of 0s. We're gonna get the binary number, and we can put the binary number into. Oh, I look great. We're gonna put the binary number in a counter, right? And then check the second, right? So we check each row, and after we check each row, we'll have a counter to tell us how many times each pattern has occurred. And if we have more than 2 patterns, that's a no-go. If the number of 1s do not equal the number of 0s, or like just too many, that is a no-go. And there's also one more we can check. Like if we have, say, 3 1s, let's say I have 5, right? We have 3 1s and 2 0s, and later on we have 3 0s and 2 1s, and that is a no-go. Wait, is that a no-go? No, that is a go. Because if I have a 1 here and I have a 0 here, no, that's a go. Yeah, that is a go. So, but still, the end result is, it's a good question. So let's say here I have two. So the pattern, right, with extra 1 is more than the pattern with only 1, right? I will hit a 1 here, 0, 1, 0, and 1, right? Basically, if it's even number, it'll always be the same. If it's odd number, if it's odd number, it depends, right? Depends on the number of ones. Let's just say if it's even number, then everything should be the same, right? If it's odd number, then each row shall be different, right? If it's odd number, then each row shall be. So if it's an odd number, of course, if it's odd number, each row will be different. But we need to have so the patterns, right? So each one will be different. So we'll have still 2 patterns, and it's fine. So I have 2 patterns, and one will have more 1s, and one will have more 0s. And yeah, it doesn't matter which one is more. So it's fine. It's fine. Yeah, so we record the number of times each pattern occurs. Then we check, right? And then we do the columns as well, and we check. If both pass, that means we end up with 2 patterns for rows, right? 2 patterns for rows. Two patterns for rows. Two patterns for columns, and then we have the same number, or this valid number. Now we need to figure out how many moves we need to get, let's say, get a rows to set. Now, the next question is, now the 2 patterns we have, is it even possible for them? Because if we have 1 pattern, right? We have 1 pattern, whatever pattern it is. Whatever pattern it is, we can swap our way to form the right. Swap our way to form. There gotta be like an optimal number of swaps. Right? So this position we need 1. This position we need a 0. Oh wait, no, this position is 1. Good. And this position, this is 0. So we just do 1 swap. So basically we just read through, right? Well, hold on. At most, I think like if we start from 1, right? If we can turn that into, we can just say 1 position, 2 position need to change, right? Isn't that at most is n divided by 4? Because no matter how you scatter around, right? No matter how you scatter around, because a position, if I set a position, say we start from 1, well, the first position will always be correct. And so the first position is always correct. And now I look at the second one, right? The second one, if it's wrong, if the second position is wrong, then we must swap it with another position that we can swap with. Right? That means there's another position that's also wrong. So we do 1 swap, right? And then we move on. And we move on to the next wrong position. And then we do swap. And then by going half the length, we will have swapped all of them. Right? We will have swapped all of them. And let's say and we say the first position is right and the second position is wrong. I would say the third position is wrong. Let's say first position is right. We say whatever we do, the first position we always say it's correct. And the second position will be wrong, okay? And the third position, let's say it's also wrong, which will make it actually 0. Next position will be wrong, which is supposed to be, it's a 1, right? And then in that case, we can just claim the first position is wrong because everybody else will be correct. And we just run 2 wrong, just run 2 times, right? The first time, we claim the first position is correct. The second time, we claim the first position is wrong. And then we run 2 rounds and see which one gives us the minimum number of moves to get the rows, get one of the rows in check. And then once we get that in check, we need to see if the other one is also in check. If the other one is not in check, which is possible, if the other one is not in check, right? So I have to reswap and the other one is not in check. The other one needs to make further moves. And if that makes further moves, will we destroy the pattern we made for the first one? Is it possible? Not really, because the moves made on the other row, it could be equivalent move here, right? It's possible. It is possible, right? So what if I have, should be this, right? What if I hold on. The move for 1, if it's the same value move, and on the other side shall be the same value move as well, right? If it's a different value move, it shall also be the different value move, because if it's a different value, I mean, you will not swap the same value because it doesn't give you anything, or it just results in the same. Like if it's wrong, like here, we say this is correct, and this is wrong, and that means something must swap with it. So when you swap, you always swap different values, right? So when you swap different values, if on the other side is the same value, then it's no go. So on the other side must also be a different value swap, right? Which means if every value swap, if every different value swap is also a different value swap on the other side, and the other side, the other pattern is different from you, so that must be a reverse pattern, right? That must be a reverse pattern from you. Which means it's only possible, the swapping only possible if the other pattern and you, their end must be 0. If their end is not 0, right? If their end is not 0, if the end of the other pattern is not 0, right? Then what's gonna, like, if it's 0, 1, 1, 0, and the other pattern is 1, 1, 0, 0, right? If their end value is not 0, then what's gonna happen is, no matter what you do with here, right? So it's 0, 1, 1, 0, and 1, 1, 0, 0. Whatever you swap, because you swap the different values, right? Because that's why it's wrong. You want to swap. And the other ones, it will always happen that they will be the same value. So when you swap this one will not change. Which means that's the third check. You have 2 patterns, and the 2 patterns, their end value must be 0, right? And then we are guaranteed that once one of them is correct, and the other one will be correct as well. Okay, let's try it. We did a lot of analysis on this. So basically we just like, there's no, okay, I'm not sure if this analysis is correct, but based on what I have now, what I think is this one does not require anything, any of the dynamic programming or nothing. Like I'm not even talking about dynamic programming. It's just analysis, just all analysis. I could be wrong, so let's see what we get. Yeah, so basically what we're saying is we're gonna do checks, right? We're gonna do checks. We're gonna do the rows first, right? Do the rows first, and we can actually make it a move. I mean, let's just say this one we'll check for the rows, right? Check for rows, and then we can turn the columns into rows, and then we run the same function. So we're gonna call it def helper, right? Which is just gonna check the I just say mat, right? We're just passing a mat, and then this one will return me an int. And then we're gonna check for the rows. So what we're gonna do is for row in map, right? And then we're gonna have a counter. Say from collections, import counter, right? So all we're gonna do is collection in map. We're gonna find a pattern. I'm going to count the ones and zeros first, right? So what we're going to do is we're going to count. And what it also could be, then their end value will not be 0. Yeah. So have a counter. It's going to be a counter, right? And then for each row, and for each one of them, and then I need to know the pattern. That's why pattern is going to be 1. Now pattern is going to be 0, and then for I, right, in range, let's say n equals landboard. Alright, so I in range, let's say from 0 to n. So it's going to be this one, left shift. Right? So whatever value we have, we're going to do left shift. How many do we left shift? So let's say for in range n, right? That is the index. So I'm going to say pattern plus equal to, I can say or equal to mat, right? Row I, right? Row I is this, and the left shift how many? Now this one need to left shift two times. The left shift 1 time, left shift 3 times. So that's going to be n minus I minus 1, right? Be very, very explicit on the logic here. Right. So n is 4, minus I is 0, minus 1 is 3. So this is 1. So 4 minus 1 is 3. 3 minus 1 is 2. So left shift 2 times. This is 3. 4 minus 3. So yeah. So this is the pattern, right? And we need to have a count, 1 count, right? So 1 count is going to be 0. So pattern is equal to this, 1 count plus equal to int row I is equal to 1. So once we finish, let's be more cheeky here. Okay, so 1 count is 0 plus here. So once we've done this, we have the pattern, right? And we have the 1 count. So we're going to say if 1 count minus n minus 1 count, right? If this one, ABS, is larger to 1, then immediately we return minus 1. That's a no-go. We cannot do it, right? Return minus 1. Otherwise, which means the count is correct, then we say counter pattern plus equal 1, right? Now, once we handle all the rows, right, all the rows, and we come out, we're going to say if len counter is larger than 2, or more than 2 patterns, or we only have 1 pattern, larger than 2, is not equal to 2, right? Return minus 1. Now we have 2 patterns, and then we need to get the patterns, right? Get the patterns. How do we get the patterns? So we're going to say pat1, pat2 shall equal to counter dot keys. Actually, I'm not sure if this usage is correct, so I'm going to try it. So from collections, import counter, right? Oh, counter and a equals, let's say counter 1 2 1 1 2 2. Man, I keep just. This is this. This counter. So a equals this. Can I say pattern 1, pattern 2 equals a dot keys? Can I deconstruct? Oh, I think I can. Yeah, I think I can. So these are the patterns. I'm going to say if pat1 and pat2 is not equal to 0, return minus 1. Right? Return minus 1. Otherwise, now we can say, now we can try. And we just go through the pattern. Right? We'll go through the pattern, and then let's say one of the pattern, we just need to make minimum number of moves. So at this point, we are certain that the chessboard can be created for each row, right? This is why we're certain that at this point we're good. And actually, if the rows we're sure, right? Which means we can, like, when we're talking about swapping columns, we can make the rows good. But that also means we can make the columns good as well. Does that mean does that mean we don't even have to check the column? Like, we're doing row by row, right? We check if the rows are good. If the rows are good, does that mean the columns are good as well? That's a good question. If the rows are good, we want to have 2 patterns in a row, right? And which means we have the same, like on a row, on each column, we only, like each column will have, like if there's 2 patterns, right? So for each column, the column wise, we only have 2 patterns as well, because at each position, for each column, we want a column pattern to have only 2 patterns. So if the column, we have different patterns. Yeah, I think once the row is done, the columns are done as well. We can just directly check the column. We don't have to even worry about the row. Yeah, we don't have to worry about it anymore. Is that true? If the rows have been configured, right, we only have 2 patterns, and plus only have 2 patterns, so they are exactly the same, right? So they're exactly the same for this So they are exactly the same. And they are exactly the same. And we'll also check the number of patterns. Oh, we forgot to check the number of patterns. All right, and if counter, say pat1 minus counter pat2, and the absolute value is larger than 1, that's also return -1, right? So the number has to be 0 or has to be only 1. So once that, and then the columns are configured as well, right? This is a configured number of 1 count and 0 count, because we only have 2 patterns. So the number of occurrences is, and the 1 pattern will represent the 0, the other pattern will represent 1. So this is for the pattern, and this, and we only have 2 patterns, right? Because we only have 2 patterns for the rows. Therefore, we will only have 2 patterns for the column, because for each column, there only exists just thinking, I'm thinking. So I have 2 patterns for the rows, right? How many patterns can there be for the columns? So it's either this or this, right? Either this or this. And for the columns, even if they change, because I only have 2 patterns for the rows, yeah, there will only be 2 patterns for the columns. That's true, because I only have 2 patterns for the rows, so there will only be 2 patterns for the columns. So this one's check. So the only thing not checking is this one. So if the rows fit this, will the column fit this as well? Columns, if the rows fit, right, will the column fit? I'm saying is, would it be possible if the rows fit, the n is 0, will the column not fit? Well, if the column does not fit, if the column does not fit, that means at a certain position, it's supposed to be, let's say, it's supposed to be, oh, hold on, the 0 is actually not, so it shouldn't be exclusive OR, right? Because I was just thinking, if it's all zeros, right? If it's all zeros, yeah, it should be exclusive OR. Exclusive OR. Exclusive OR. No, it can just do OR. No, it has to be exclusive OR. I want each position to be different, right? So it has to be exclusive OR if it's not equal to 1 left shift n minus 1. Right, as that's exclusive OR, what it is. It has to be 1, 2, 3, 4 minus 1. Then we turn minus 1. So that's on the rows, right? We compare the rows. And then what about the columns? For each column, the pattern of columns. And I can run the same check, but I feel like it's unnecessary because the columns we might already checked. Like if the rows fit, right? If the rows fit, and I know there are only 2 patterns for the columns, right? And the 2 patterns for the columns, it's about how the rows are distributed, right? It's about how the rows are distributed. Would it be possible that it's not? Like exclusive OR will not give us. I'm talking about like this is 0, 1, 0, 1, right? 0, 1, 0, 1, 0, 0. Then, if that is the case, that means we'll have, let's say we have 2, so we know there are 2 patterns, right? And then, at a certain position, the other pattern, we have a value that's not supposed to be there. But if that's the case, what do you mean by not supposed to be the same, right? So if that's the case, then the row will break. Therefore, if the row does not break, then the column does not break. Therefore, we do not have to check column. Therefore, this do not have to be a separate function. We just run this check on the rows. When the rows are good, then we are good. So at this point, we're certain that just what can be created, right? It can be created. That's it. So that's the, at this point, we know, right? Okay. Now what? Now we just need to check the rows, any row, and check the first row, and then see how we need to manipulate. So what we're gonna do is just put in. Can we make this like? Because what we're given is, let's say 0, 1, 1, 0, right? So the possible answer is 0, 1, 0, 1, or 1, 0, 1, 0. Can we like make some change? Let's say exclusive OR, right? If we do exclusive OR, then the first one will give us 1, 1. The second one will give us 1, 1 as well, right? Then we count the number of ones and divide by 2. That's the number of moves, minimum number of moves we need to make. That's 1 move, right? So what we can do is just check with 1, 0, 1, 0, 0, 1, 0, 1, and we pick the one that gives us the smaller number of ones, and we divide by 2. Okay. How do we count the number of ones? Okay, iterate through or whatever. So valid 1, valid 2 equals. How do we make this? How do we make this? Like 1, 0, 1, 0. How do we make this? Is it just like left shift? And then how do we make the other one? We do a not, right? We do a not. Hold on. So let's say A equals 1, 0, 1, 0, 1, right? So binary A? No. How do we turn into a binary? Actually, don't know. Int A B. Wait, how forgot. Turn string to binary number. Format Convert string to binary. Binary string to binary literal. OB, not OB, 0B, my bad. So the 0B, so has to be 0B. So A is this, then we can say int A. 2. Right? So what we want is, let's say we negate it. Oh, that's not negate. This is negate. So we do this, and then let's binary it. Take a look. So, ooh, that is not correct. Minus 0. No, 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 no. 1 0 1 1 0. What's that called? Binary negate? Binary negate, is that the one? Negation? Not. No, that's not what I'm looking for. Turn each binary bit to opposite. There's got to be something simple. What, really? There's no such a thing? Look at these answers. That just feels... Wait, there's no simple... Complement. Complement. 2's complement, that's fine. But negative is 2's complement. Hold on. Binary string. Well, what was the question? Oh, somebody wrote. I actually don't know. How far does sign bit extend? Now I feel like this is just oh, what are you doing? What are you doing? If I have 1 0 1 0 1, I just need to do a 1 1 1 1 1 and run an exclusive OR. That's it. Ah, yep, that's how you get it. Okay, so all right, where are we? So we want 2 valid values, right? So the first valid value, bit masking. Yeah, bit masking. The first one would just be Now, first one cannot be bit masking. First one, you have to do it. You have to do it. So, oh shoot. So valid 1, so it starts with 0, right? And we're gonna say is for, let's say we're gonna shift 1, right? It's gonna shift 1. So for I in range, or 10101, right? So we shift this will be 4. So shift 1, 2, 3. Shift 3, and then shift 1. This one shift 4, then shift 2, 2, then shift 0. All right. 4, it's gonna be for I in range. Let's say in range n. Actually, no, not in range n. In range n minus 1, right? The last value shall be minus 1, and then minus 2. So 3, and it's 4, and we do 3, and 1, and that's it. So value 1 or equal to 1 left shift I. Right? Again, let's put this one in just in case. So left shift I, and then valid 2 is going to be valid 1 exclusive or 1 left shift n minus 1. Right? So that will give us a 1, 1, 1, 1, 1, and then we do exclusive or is going to give us the other value. So now we have 2 valid, right? We have 2 valid. So say obtain the 2 valid states for each row and column. Now, what we're going to do is just take the first one, right? We're going to take the first, and we do, and what did I say? Like exclusive OR, right? Yeah, we do an exclusive OR and count the number of ones. So we do exclusive OR. Can I count? So A is this, right? A dot, do I have count? We do. Yeah, we have count. And it will be an even number. So what we're gonna do is we're gonna do pattern 1. We already have it. Pattern 1, right? So we're just gonna do pattern 1 with the 2 values, right? And then say move column, column swap shall equal to, let's say, because pattern 1 and pattern 2 should produce the same value. So pattern 1, exclusive OR, value 1, right? And then we're gonna turn this into a binary string, right? Then we'll turn into a binary string. Yeah. So turn into a binary string, and then we're gonna dot count number of ones, and we'll do the exact same thing, and this one will be a value 2, and then we're gonna take the minimum of these. How do we get a pattern column? So this wouldn't get swaps for column. Now next one is swaps for row, right? Now we're gonna get a pattern for each column. So the pattern column equals 0, right? And for J in range n, same thing. Then pat column, right? Or equal to board J, right? Board J, and first. No. Yeah, yes. This is the row, this is the column. The first column, this one, and I'm gonna go left shift. I think the same thing, n minus j minus r minus 1. That's the number of shifts we want, and we're considering this as the least significant bit, right? So we start, why do you always have these wrong thing? So we start j equal to 0 is here. So this one, oh, hold a sec. Hold a second. That is not correct. That's actually just, I think it's just shift shift j, because this is the first element, is also the smallest. So shift 0, shift 1, shift 2, and shift 3. Yeah. So that is that, and then we can copy and paste this. We just swap pattern instead of pattern 1. It's gonna be pattern column, right? So pattern column as a column swap. And once we've done both, we'll just return row swap. No, it's not. It's gonna be row swap. So row swap plus column swap. I think we'll pass the test case for the 2 or the 3 that's given, but I'm not so confident. Alright, so this one will give us 2. And then the second one is 0, 1, 1, 0. Alright? This one will give us 0. I don't have to move. The next one is 1, 0. I remember. 1, 0. Give us minus 1. And of course, the test case we contributed. Right? And then this is going to be grid. So grid, board. This one will be move board. Name mat is not defined. Of course it's not defined because it's not mat, it's only board. Try it again. Oh! Alright, wait, the logic has some issues. Where do we find the problem? One count for 1. What's the problem here? Where was the problem? Let's focus on the first one. Shouldn't be these, right? Let's just see. Probably here. Yep, that's what we have. So what is the value? Let's print. That's a bin pat 1 and bin pat 2. Let's see if the 2 patterns are correct. Oh, the 2 patterns are not correct. But still, even if they're not correct, even the exclusive OR, what is the exclusive OR between these two? No, it's exclusive OR. Wait, what's bin pat 1? Exclusive OR pat 2. Should be this, right? And then with left shift, pretty sure we should need to do this. Because I think the minus take precedence. I sure can do this. Alright. Yep. Oh no, this one needs work as well. So should be exclusive or this, right? We can actually create a mask. So n equals this, counter equals this, mask equals 1 left shift n minus 1. Right, that's our mask. So all of this can be replaced by mask. And of course, with mask, we need to put this. So that's that. Now we can try the others. Oh, this is not correct. Hold on. Why? I'm pretty sure we passed everything here. And then, right, let's just first check bin val 1 and bin val 2. Oh, that's not correct. Bin value 1 of 2, right? So 2 minus 1 is 1. Which already is shift 1. Oh my god. It's or. Oh my god, I just typed not equal to. There we go. How does the other one pass that? I'll never know. Now the first one doesn't pass. Okay. Come back to fix. Why? Again. Make sure the valid. The two valid values are correct. 1010, 0101. Yeah, the two valid is correct. And then what's pattern 1? Oh, I forgot to divide by 2. I can just do divide by 2 here. Let's just divide by 2 here, so it's more explicit. Divide by 2. Number of ones divide by 2. I forgot to divide by 2. Alright, now these all pass. Let's try it. Alright, submit. Pending. Wrong answer. Nah. Output 0. Expected 2. Huh. How is this output 0? Come on, man. Come on. Oh, the number of ones. Hold up. Then what? 110, 001, and 001. So we pass all the check. Now we have 101 or 1010, right? So 110 exclusive OR will count 2 ones. If we go 010 exclusive OR, we count. I see. That is a problem. If it must be odd number. It must be even number. Cannot be odd number. Ooh. So I have to separate consideration. get the number of counts, not take the minimum, all right? Yeah, but because in this case, we do 0, 1, 0, right? We do 0, 1, 0, and we want to swap 1. We cannot swap 1, we have to swap 2. So column swap 1 will equal to this, right? And then column swap 2 will equal to this. So I have 2 swaps. Now, the swap must be even, right? So column swap shall equal to the minimum of column swap 1 if column swap 1 is to a 0. It has to be even. If it's even, then we do this. If it's odd, then math.inf, right? So I import math. Right? The second one is just column swap 2. If it's even, otherwise we do this, minimum this, divided by 2. Right. So I do the exact same thing. It's row swap. So all these column swap talk, swap for so this one be swap to row swap, right? And then this is now pattern 1. These are pat column. And then with this, I think we'll get this one correct. Shall be 2. Oh, the hell. Oh. This needs to be a row swap. There we go. Now we pass. Note that the number of ones after number of ones in column swap 1 and column swap 2 must be an even number, right? Must be an even number for a swap to be valid. Yeah, that's the trick. Which we're just gonna, alright, we'll try it again. Oh, we just added so much more. I hated it. I hated it. I want to write like a function to do this. I don't have to repeat. I want to write a function to do this. I can actually write lots of functions. Like producing the pattern can be a function. That's fine. Yeah, I'm going to rewrite this. So def, let's say build pattern, right? Build pattern. So what we're gonna give is right. We're gonna give is main index, and oh, I cannot give main index. We're just gonna give. What do we give? We give a row, right? That's what we're gonna give. We give a list. All right, we give a list, and That's it. That's all we need. Just give a list and then return an int. That's a build pattern. So basically, we'll just do this. Oh, but the pattern, that's fine, because a pattern, we can build it top down or bottom up. It doesn't really matter that much. So basically just say, for this in range, len list, right? And pattern gonna be list 0, and the left shift n, I'm gonna do n equals len list, right? And then from len list, and then well, n equals len list, and this is n, right? And this is also list. Oh, one count. Oh, I think we can use the other one as well. Say a equals 1, 1, 0, 0, right? Can I do a dot count? Yeah, I can do a dot count 1. Yeah. So we don't need this. And then we return pattern. I have to do pattern equals 0 as well. So this is the build pattern, which means we don't need any of this. All right. All we need is one count equals row dot count 1. Right. If this and this. Otherwise, pattern we can just say self dot build pattern row. Right. And if len is not, I'll return key. If this is not, return this. Good. And then this is just this is the valid, the two valid. And then we need to do swap count. Right. So swap count. So def swap count swap self. So we'll have a pattern and we'll have valid. So valid 1, valid 2, they're all integers. Right, this one is an integer. Valid 1 is integer. Valid 2 is integer. We're going to return an integer. Right? So you basically just copy this. Right? So we're going to say swap 1, swap 2. So it doesn't have to be just swap 1 equals pattern, and a minimum. Do have to change everything. So this one, no, and then you swap 1, swap 2. And swap. So it's not going to swap equal to, just going to return minimum this. Yep. So this count swap. So what we need to do is return count swap pat1, val 1, val 2, right? Pattern 1, val 1, val 2, and plus count self.count. Self.count. And then this is also self.count swap. This is going to be a column pattern. And a column pattern, we need to build it first. All right. So we need to build it first. So it's going to be self.build pattern. So this one would have to do this way. Val 1, val 2, right? Now to build a pattern, the pattern needs to get the first column. So the first column we can get board J, I put I 0, right? For I in range n, right? I in range n, that's what we get. And give me a different one, but it doesn't matter which way we go. So that's the pattern, and then we can reduce this. Run it. All right, so pass everything. Now, try it one more time. Submit. Yep, passed. So yeah, it's not that difficult, all right? But it just takes a while. Okay, so this problem is not difficult in terms of using some smart algorithm, but it is complex because there are a lot of tricks to go through to help one realize that this problem does not require smart algorithm. First, we identify that to make a chessboard possible, each row must have equal number of ones and zeros, or the number of one value, only one. All right, I'll be back. Let's go. Yeah. I think I see the pattern. That's fine. I told you I enjoy doing it. Alright, back. Just keep writing. You can have a 1, 0, number 1. 1 larger, right? That's 1. If this requirement is not satisfied, we can return -1 immediately, right? Second, what's the second? Among all the rows, there must only be 2 patterns. This is because the chessboard, right? In the final chessboard, there are only 2 patterns for all the rows. And since swapping columns, right? So swapping columns do not add or minus row patterns, we must start with 2 row patterns. Third, the 2 row patterns must complement each other. Otherwise, there must exist some swap in one row that will have no effect on the other row. Here's a weak reasoning. What I'm supposed to say. I'm going to give an example. For instance, right? E.g., pattern 1 is, let's say, 0, 1, 1, 0, right? And then pattern 2 equals 0, 0, 1, 0, right? Then swapping pattern 1, swapping the first 2 elements of pattern 1 will not change pattern 2, which means we cannot make both patterns correct at the same time. So this requirement can translate to path 1 exclusive of path 2 must equal to 1 left shift n minus 1, right? Okay, so that's 3 requirements so far. 2 patterns, and fourth, the number of row patterns, the number of each row pattern must be equal, or the difference not larger, or the difference, what did we say? Or the row pattern must be equal or differ only by 1. Differ only by 1. Right? This is actually to satisfy the column values, but I think it's very intuitive. Right, so interestingly, once the rows satisfy the above mentioned 4 requirements, the columns automatically also become valid. And then we just need to find the minimum number of moves to swap the rows and the columns, add them together, and we have the result. To find the minimum number of swaps, we create masks of the two valid final state, right? Final state. It's called val1 and val2. We then, since we only need to check for one of the row and column pattern, we use exclusive OR. Right, we use exclusive OR. I think exclusive OR, yeah. We use it's here, exclusive OR, and then count the number of ones in the result. The number of ones indicate the number of mismatches between the current pattern and the valid pattern. Also, the number of ones must be even because that indicates, because each pair of ones indicate a swap. Odd number of ones doesn't work. Alright, so the runtime is, good question, what's the runtime? On squared, that's on squared. Build pattern is on. I consider this as O1. So that's on squared. This is O1. This is O2. This is O1. Build the valid, that's on. And count swap is O1. So on squared. On squared. Time complexity. Alright. Let's check here. We had 76 milliseconds, so 76 milliseconds, or, well, we got an 88% ranking, pretty good, huh? Yeah, considering the runtime has pretty high. Okay, I did pretty well actually. Yeah, I did pretty well. It took a long time though. It took about an hour. I think I can speed it up. It's just like at a certain point, I starts to trying to make sense of everything, and I got stopped at somewhere. Oh, it's because my laptop is slow. So if I try to click here, and then some other UI gets rendered, and I just click the wrong place. So this is a LeetCode, what, 780 something? I don't know. Oh, yeah, no solution. 782. People complaining, say, "Oh, this is not really a." I try my best to find the swaps, and then it turns out you just need to check. I guess people are gonna. What's a math solution? Two new types of rows, and if n is odd, what happened? We wash it tomorrow. It smells good. feature type and is even, this should be this and this, the same for columns. Sufficient enough. Now for the first row, if n is odd, we have one option. We need to transform. If n is even, we have two options. We need to check. Yeah, I think it's the same. I'm just writing a very different way. Now, I'm not gonna follow this because I think we have the same idea. So I'm just gonna stick with what I have. I can post hours. I mean, it's fine, right? So let's create this. Build a pattern out of a given list of ones and zeros. This is count the minimum number of swaps to go from path to either val 1 or val 2. Okay. So we can just say param path current pattern one of the valid final pattern on the chessboard, right? And then val 2 is the other valid, right? Now then the number of ones in the swap in the result of XOR must be even for a swap to be possible. Okay, and then look at this, blah blah blah, and this is, we don't have to do lists, it's fine. Then we have this. Yeah. Obtain. Yeah, we can do ours. Yeah, basically I'm just lazy. I don't want to check what he's saying. Wait, it's discussion. Come on. A new one. 3. What should I say? Huh. I actually don't know what to say. I don't know what to say. The title. Four rounds of checks. Right, that's what we have. 4 rounds. We have first, second, third, and fourth. Okay. 4 rounds of check. Validation. 4 rounds of check before counting counting minimum, min number of swaps. Right. And then blah blah blah. Okay, post it. All right, that will be it. We did it again. I'll see you guys tomorrow. Adios.